The Dragon and the CoCo may look very different on the outside, but look inside and it's a completely different story. What happens when you try to use a game from one system in the other? And could we do something about it?
Hello and welcome back to Noel's RetroLab. I really wanted to participate in this year's SIP Tandy, but I was frustrated that the closest thing I had was a Dragon computer, which is kind of similar to a Tandy Color Computer, but it's not really a Tandy. So I started looking for a Tandy computer, but it turns out they're not very common at all in Europe. Eventually, I found this one on eBay, and you might have even seen it in a previous Mail Day episode. It was listed as untested/not working, and I was really excited to make an episode repairing it and restoring it. So I went to turn it on, and it worked. That was rather disappointing. So with barely enough time to still make it to SIP Tandy, I decided to focus the video on something that I had heard repeated many times. Is the Dragon computer really a clone of the Tandy Color Computer? Let's find out.
Let's start with a really quick overview of when these computers were released to understand the context. Tandy Corporation released the TRS-80, later named Model 1, in August 1977. As the name implies, at its core, it used a Z80 CPU and it had pretty much nothing in common with later color computer models other than the TRS name. It was followed up by the TRS-80 Model 2 in 1979, but that was intended more as a business machine. It was in September 1980 that the TRS-80 Color Computer, or CoCo, was released. This was a completely new architecture based around the 6809 CPU, and it was definitely intended for the home market. The TRS-80 Color Computer 2, or CoCo 2, which is the one I got from eBay, was released in 1983. It's essentially the same architecture, but with reduced internal components, higher memory options, and a new case design. And just for completeness, in 1986, Tandy released the Color Computer 3, which again was very similar to the previous CoCo models, just with more memory and slightly better graphic capabilities, but it was still similar at its core. To put things in context, the Commodore VIC-20 wouldn't be released until 1981, and the main competition for the CoCo at the time were the TI-99-4, not the 4A, released in 1979, and the Atari 8-bit family, also released in 1979. So where does the Dragon fit into all of this? The first Dragon model, the Dragon 32, was released in mid-1982, so that's almost 2 full years after the original CoCo launch. Considering how quickly computers were designed back then, they could have started development way after the CoCo launch, and even after seeing its initial success. So that's the first indication of the Dragon being a potential CoCo clone. A year later, it was followed by the Dragon 64, which was a very minor improvement, just adding 64K of RAM and a serial port. That launch coincided with the CoCo 2, which is why I picked these two models specifically to compare against each other. The company Dragon Data didn't fare well and had a very rocky few years afterwards, but I won't get into that right now. That's a story for another time. This episode is sponsored by PCBWay, but more on that later when we build some custom PCBs. So here they are, the two models side by side. One interesting bit is that this is a PAL CoCo 2, not an NTSC model from the US, but since the Dragon is also PAL, it will make for a better comparison. Interestingly, the Dragon was briefly marketed in the US under the Tano brand, so there are NTSC versions of the Dragon out there, just not very common. Externally, the computers seem pretty different, but once you look at them closely, you realize that's mostly because the cases are so different and the fact that the Dragon has an external power supply and the CoCo has it internally. But if you look more closely, the similarities will be obvious. Look at the keyboard. The layout is identical. People may not think much about that today since we're used to computers having a similar keyboard with a couple different keys. But back in the early 80s, just about every computer had a wildly different keyboard layout. Clearly, Dragon just copied it straight up. And by the way, even though the CoCo 2 has an improved keyboard over the original chiclet one, I have to say the Dragon keyboard feels a lot better. It feels more robust. So they may have copied things, but at least they did a good job with it. Most of the ports are the same. The cassette port is a DIN 5, which actually makes sense given the amount of signals that you're passing through it, and even the Amstrad CPC used the same format years later. But for example, both computers have 2 joystick ports. They're very similar. One of them is a DIN 5 and the other one is a DIN 6. All of the pins are the same, except that the Dragon drops the middle pin for the second fire button. What a coincidence. Both computers also have a slot for cartridges, which is nothing unusual, and most other computers of the time, especially in the US, had those. The really interesting part is that both the physical format and the signals themselves are identical. That's just in case there was any remaining doubt whether the Dragon copied the CoCo or not. The biggest difference between the two is the video out. The CoCo only has RF video, but the Dragon had RF and composite signal. It's true that back then the great majority of the users would have just used the RF input on their TVs, but today a composite output is extremely useful. I'll look to see if it's possible to add a composite video output to the CoCo later. The other major difference is that the Dragon has this other connector that's a parallel port intended for a printer. It's interesting that the CoCo doesn't have anything like that. Alright, so what's the story with the Dragon? Did they really set out to make a clone of the color computer? Apparently, it's not quite as straightforward as that. But to understand that, we need to look at what's inside. After working on a Dragon 64 for a couple of weeks, my first thoughts when seeing this board is, this is tiny. And it really is. It's amazing that the power supply is inside the case, and yet it only takes that little bit of space. On the Dragon, you have a bulky external power supply, and then a whole subboard for generating the right voltages. To be fair, this looks like a cost-down version, and there are other color computer boards that were a bit larger, although nothing quite as large as the Dragon. And part of it is that the DRAM is tucked away in this daughter board, so removing that and putting it side by side gives a better idea of the real size of the board. So let's have a quick look around, especially looking at the differences with the Dragon. If you haven't seen last week's episode on the Dragon 64, I recommend you do that now. This comparison would make a lot more sense that way. I'm putting a link in the corner right now. The CPU, a 6809, is right over there, and the RAM is in the daughter board like we already saw. And it's also organized as 8 4164 DRAMs, just like the Dragon 64, although again, there are different variations on the RAM on other versions of the CoCo 2 board. The SAM is a slightly different number. It's a 74LS785 instead of 74LS783. That's just a minor improvement supporting different RAM and ROM types, but other than that, it's the same. The two PIAs are over there under different numbers for some reason. And then we get to the weird chips. We have this XC8652 chip over here, and it turns out that's the VDG. It's another number for an MC6847T1, which is a slightly improved and pin-compatible version of the one that we find in the Dragon, the MC6847. Initially, I thought maybe the CoCo 2 exposes some of the improvements of this VDG, but as far as I know, it doesn't. You may be able to unlock those by doing weird things, but not with the stock CoCo 2. Then there's that chip labeled YM2211 on the corner, and that's probably the ROM, although again, the chip number doesn't come up. Maybe that's the new kind of ROM that the SAM interfaces with. It's also interesting that the ROM has links next to it for 64K or 128K. That must be referring to bits, which is how usually EEPROMs are classified. So 64K would mean 8 kilobyte EEPROM, and 128K, which is what it's set to right now, is a 16 kilobyte ROM. And down in the corner, we have another chip I had never heard of. In doing some digging, I found out that both that chip and the small one next to it are part of the video signal encoder, which makes sense because there's the PAL crystals as well right there. I imagine that a lot of the other stuff surrounding them is also involved with the PAL video signal. Initially, I thought that the composite signal was generated inside the RF modulator, so the good thing about seeing that is that it should be possible to tap somewhere along the way and create a composite mod for the computer. Actually, let's do that right now. So as an experiment, I've set up a very simple composite mod. This is very similar to the ZX Spectrum one. Specifically, this is like the one that I did with the Inves Spectrum, because the composite signal that I was able to tap into right before it was fed into the modulator was a little too weak to display on a monitor directly. So this pretty much just takes care of amplifying it a little bit, and then we have a little bit of control with that variable resistor. And then I've hooked up the output to a DIN5 connector, so we can actually use the same Dragon cable, but really any composite cable will work. So I'm going to connect both the composite cable on the new connector and the RF cable in the original RF modulator. That way we'll be able to swap between the two easily and compare the two images. Let's check the results on the CRT TV. First, let's look at it again with RF. And as you can see, the characters have light halos around them and lots of weird pixel patterns. And for some reason, this image has a lot of contrast. And then when I switch to composite, well, it definitely looks better, although I still see some of those weird pixel patterns like the VIC-20 had. I suspect this is a case where you'll see significant improvement with an S-video mod over Composite. Still, it's good to know that it was relatively easy to output Composite video in case I end up wanting to make this a permanent mod. And so back to the board, what's missing in comparison to the Dragon? The only thing that's really missing is that chip that we had for serial communication. I believe that the CoCo 2 that's done through a PIA, and so what we're really missing is the parallel port of the Dragon, which was using a PIA for that. And that's about it. The rest is pretty much the same between the two computers, even though they look so different. One of the reasons those computers are so similar inside is because they're made from off-the-shelf parts. Notice there isn't a custom chip like the ZX Spectrum ULA or even the Commodore 64 PLA. The big three chips are the 6809 CPU, the 6847 video display, and the SAM to tie them all together. Those chips were designed by Motorola to work together, and they even presented a suggested design in their data sheets. So Tandy obviously just grabbed that reference design and fleshed it out with I/O support to form a fully working computer.
Did Dragon Data do the same thing and come up with the identical design? Not a chance. If you give me the Motorola's reference design and ask me to make a computer without any other information, I may end up doing some of those things in common with the CoCo, but not everything. And especially not when it comes to things like the cartridge shape and the exact pinout. That could have been anything. So in my mind, it's totally clear that they just copied the CoCo design. But to really decide if the Dragon is a clone, we need to look at compatibility. Can we use CoCo software or even hardware on the Dragon? And what about the other way around? Let's find out.
Let's start with the biggest difference. The CoCo and the Dragon have different ROMs. That's probably the main thing that kept lawyers away. Even though the ROM implementation was different, the details of the actual architecture were, again, very similar. Both Tandy and Dragon Data licensed Microsoft Basic, and along with Microsoft Basic came a series of guidelines on how to organize things internally. That probably explains why the memory map is exactly the same between the two platforms, for example, making the computers even more similar than before. Surprisingly, even though the basic language is the same, the actual basic tokens, so that means the values that represent the different parts of the basic programs, are different between the two. So you can't take a basic program from one computer and load it in the other. You need to retype it again. Seriously? I smell lawyers again. But perhaps the weirdest difference of all of them is the keyboard interface. The keyboard is read by the PIA and it's done from the same memory address on both systems. But for some bizarre reason, the keyboard matrix is different between the CoCo and the Dragon. So even though both computers have identical physical keyboard layouts, they're wired slightly differently underneath. Why? I mean, you've already copied everything. Why not copy that last detail? After looking at all of this, I think the Dragon is an exercise on how close you can get to another computer and still have some legal grounds not to get sued. I can't explain it any other way. Okay, so let's look at the software itself. We know a basic program on one computer won't run on another one, but what about a program written in assembly? I believe that as long as those programs aren't making calls into the ROM that are different between the two systems, they should work fine. On the other hand, for the keyboard to work, they actually do need to use the ROM functions. I don't have any CoCo cartridges, but I have a couple Dragon ones, so let's see if they work. Here's one with a really beat up packaging, Meteoroids. I suspect it's a total clone of Asteroids. And when we tried it on the CoCo, we get nothing. We don't even get past the green screen, which I know is the sign of the ROM initialization not getting very far. Okay, can't say I'm too surprised. I do have another cartridge. It's a version of the language Logo, but localized in Spanish apparently. Let's try it. And oh cool, this one actually loads. And it must be using the ROM routines to read the keyboard because it actually works fine. But since it's localized in Spanish, the logo commands are also in Spanish, which I guess it makes sense. It's supposed to be a learning language mostly for kids. So yeah, this works perfectly. I wonder how many other cartridges are out there that work 100% like this one on both systems. I'm actually curious about that Meteoroids cartridge though. I did a quick search to see if there was a CoCo version, and it looks like the same game was released on the CoCo, but with the title Microbes. Okay, I guess Meteoroids was too close to Asteroids. I went ahead and downloaded the ROM for both Meteoroids and Microbes, and I'm curious to see how different they are from each other. They're both just 4 kilobytes, so that matches. And at a glance, they sure look very, very similar. Let's look at the differences. Okay, there are quite a few differences, but they're clearly both the same game. Let's actually disassemble them so we can see where the differences are. I'm sure there are better tools out there, but I'm using a Perl script that disassembles 6809 binary into text. And let's put them side by side. And yeah, it looks like the main changes I'm seeing are mostly address changes, probably due to the different ROM routines that are using. And doing a diff of the text, yeah, it's mostly just function call differences. Let's grab the first one as an example. It's a call to a ROM function at BAC5. When we look it up on the ROM reference, that's the call that enables the sound. Okay, that makes sense. But right there, it also says that on the CoCo, that's called A976, which is exactly what we see at the beginning of the microbes game. So yeah, all those are the small changes necessary to call different ROM functions and probably also read the keyboard differently. On the plus side, even if programs don't work on both computers, it's almost trivial to write programs that work on both with just a few minor changes. It's also really easy to port existing games and make versions that work on the other computer, so you basically count on a full software library for both computers. To really drive home the point that cartridges are identical except for minor differences in the software, let's make the world's worst cross-platform multi-card system. Let's open the Dragon cartridge. As you can see, it's just a 24-pin EEPROM and an inverter gate, so there isn't much to it there. And the ROM is already socketed, how convenient. So we can replace that EEPROM with one with a microbes game and run it on the CoCo. Well, it's not that easy. There is one problem. The EEPROM in the cartridge is a 4 kilobyte 2532, which is not a type I have. Looking around, I see it's very similar to 2332 EEPROMs, but I still don't have any of those, and they also usually require higher voltages to be able to program them, and my EEPROM programmer can't handle that. However, that's a very similar pinout to the ROMs of the Commodore 64. In the past, I made my own adapters, but they're ugly and they're a pain to put together. Fortunately, there are several open source projects for custom PCBs to use a 28-pin EEPROM in place of the Commodore ROMs. And who are you gonna call to make a custom PCB? PCBWay, of course! Normally, you look for the Gerber files in the project, download them, then go to PCBWay, upload them there, set a few parameters, and order them. In this case, they're already even set up for PCBWay, so you literally just click on the Order from PCBWay link on the project page, and you're ready to go. That easy. And after a few days, here they are. I ended up ordering many because they're so small that it was the same price as ordering fewer of them, so hey, might as well, I'm sure I'll use them. And so now all we need is a PCB, a socket, and a few pin headers. Let's get building. At this point, I realized that the socket will bump up against the pin headers, so I'll use some female pin headers instead, so it all fits nicely. The headers themselves are rather large, and we don't have much room, so I'm going to trim them down just a little bit so they fit better in the EEPROM socket. And because we're using a larger EEPROM, we're going to need to tie the extra address lines to ground. Fortunately, the adapter comes prepared for that, so I'm going to solder this lead tying those pins to ground together. And there's one more thing we need to do. Because of the specific EEPROM we're using, we need pin 20 to be high all the time, so I need to break that jumper and tie it to VCC. And then we want A12 low all the time, so I'm going to solder a very small wire between A12 and ground. Now we're finally ready to try it out. But first, let's make sure that everything works correctly in the Dragon still. So I prepared this EEPROM with the Meteoroids game in it, and let's put it in the socket. That's easier said than done with those connectors. But there you go. Now we put the adapter on the cartridge. And unfortunately now I can't close the cartridge shell, not even close actually. Clearly, if we did this in a more permanent way, we would want to take less space. Actually, the easiest way would probably be to make a custom PCB for the whole cartridge, not just an adapter, that takes directly a 27C128. Anyway, let's just use the PCB directly without the case for now. Let's pop it in the Dragon, and launch it, and perfect. Everything seems to work fine. Now I can swap that EEPROM with microbes, which is why it has a C in it to remind me that it's for the CoCo. And yeah, fitting those EEPROMs is just a pain. Let's go ahead and try it in the CoCo. Nice, there you go. It looks amazingly similar, it's just the few title changes. And yeah, the game is the same. So I know I said this was the world's worst multi-platform card, but let's try making it a tiny bit better at least. Since we're putting a larger EEPROM, we can have both versions of the game in there at once and select which one we want with the jumper. For that, we need to make a small modification, which is to solder a 10K pull-up resistor on R1. That will make A13 low when we tie it to ground with the jumper, and it will bring it high when we remove the jumper, so we'll read the data from the second 8 kilobytes in the EEPROM. And there you go. So let's give it a try one more time in the CoCo, and yeah, that works great. One thing to keep in mind though is that unlike the PAL Apple IIe, neither of these two PAL machines will emulate the NTSC color artifacts. There are quite a few US games made in high-resolution modes relying on the NTSC artifacts to get some color. So when you play one of those, like this Donkey King, some of these names are hilarious, it will be black and white with weird vertical lines like this. It's still kind of playable, but not at all the way it was intended. So if you see that, it's because it's an NTSC game.
And what about hardware devices? Will they work on both computers? In theory, they could. In practice, the software that uses the device might need some tweaks from one system to the other.
For example, you could have a device on the serial port connector that works the same on both computers, but the serial port is read through the PIA on the CoCo and through a special chip on the Dragon, so I imagine the I/O will be mapped differently. Something that uses the cartridge expansion, though, is much more likely to work on both cases, unless it requires some specific system ROM calls. So let's try it. I have a Dragon disk controller that plugs in the cartridge slot. So yeah, this is pretty much all it is. We have the drive controller, which is a 2797, and we have the ROM itself, which is labeled as DOS V41, and the rest is just some binding glue. Interestingly, it has some adjustable resistors. I don't know what that's for, but it looks very straightforward. And when you connect it to a Dragon, you see a message at startup recognizing the new ROM. But when you plug it into the CoCo, you get... yeah, nothing again. I was really hoping it would work, but I suppose the additional ROM in the disk controller is intended to work with the basic ROM, adding new commands and such, so it's really too bad. I'm sure it would be possible to replace the ROM on the disk controller and get it to work with the CoCo. Just for kicks, I'll try this Dragon Drive, which is a disk controller along with a USB emulator, very Gotek-like, and as expected, nothing. By the way, CoCo SDC is a great device. Not only does it emulate a disk drive, but it even comes with a loader program that can be loaded automatically, so as soon as you turn on the CoCo, you're presented with this. And from there you can search whatever game you want to play that you have on the SD card and launch it. And the fact that it works on both platforms makes it amazing. I highly recommend it for both Dragon and CoCo owners, and especially if you own both of them.
So was the Dragon intended to be a clone of the CoCo? I don't think so. I think it was actually worse. It tried to be its own computer, not totally compatible, and yet at the same time it just copied everything from the CoCo. I'm really surprised they weren't sued to the ground by Tandy, but those were different times. And of the two, which one would I recommend? It may surprise you that I would definitely go with the Dragon. The keyboard and the composite video out alone are great upgrades, and I also like the much roomier board with more components. It makes it much more comfortable to work with it. But in the end, they are close enough that you should probably just grab whichever one you have more easily available where you live. I'm hoping to make a future video continuing to explore what Dragons and CoCos can do, looking at things like OS 9, and I also have a couple Dragon 200s that I need to repair and build power supplies for them. Hopefully those won't work the first time I power them on. And anyway, that's it for today. I hope you enjoyed the look at these two computers. I would love to hear from you about your favorite games and upgrades for either one of these computers, since they're relatively new to me. So just write some comments and I will definitely check them out. And I will see you next time.
If you enjoyed this video, please consider supporting Noel's RetroLab on Patreon or joining the membership on YouTube. Not only is that the best way to support this channel and allow me to continue making more videos, but you also get some extra perks like early access, ad-free videos, and more. Thank you again to all the supporters. See you next time.